We're going to get started on our next conic section. That's the ellipse. And what I had said was the ellipse was if you took that cone and imagine just one of the cones and kind of cut it at an angle, you would not get a circle. You kind of get a stretched out circle. That's what's called an ellipse. So let's go ahead and take a look at the two ways we see an ellipse. So in general, this is what an ellipse looks like. There's two different types of ellipses. I'll talk about those in a second. There's an ellipse that's kind of more horizontal, and then there's an ellipse that's more vertical. But in general, the points that make up an ellipse, the same idea as we have with circles, there's a center. And the center is typically referred to as h comma k, just like we do with a circle. Our center is hk. Now here's the deal. When we deal with a circle, that radius is the same all the way around the circle. So whether I'm going up, whether I'm going down, left, right, doesn't matter. The distance from that center to the circle is the radius. It's that same r. In the world of an ellipse, we have two different distances. The two different distances technically are called the major axis, which is referred to with the letter A, and a minor axis, which is referred to with the letter B. That major axis takes us to the vertex, and the minor axis takes us to what's called a covertex. So again, vertexes are the longest kind of lines in that ellipse, and covertexes are the shortest ones. Additionally, there are two other things in here called the focus or foci, and they're usually referred to with the letter C. They're referred to with the letter C. Now, we looked at the equation of a circle, and if you remember, this is the equation of a circle. The equation of a circle was x minus h squared plus y minus k squared equals r squared. That was our standard form of a circle. Well, I'm going to tell you there are two different ones for ellipses, but they look the same with just one change. So this is our like, if you want to call it our horizontally aligned one. This is where what is going to happen is when I'm looking at this one, a horizontally aligned one is going to have the equation. Again, it's going to still be x minus h squared. It's still going to be plus. It's still going to be y minus k squared. Here is where the difference comes into play. The major axis runs horizontally. This major axis A runs horizontally. It runs along the x-axis. Notice this A is along the same line as what the x-axis would be, that vertical. It's going to be over a squared. Our minor axis B runs up and down. That's going to be under our y-axis, so over b squared. And this one is going to always equal 1. So this is the standard form. And this is the standard form of an ellipse with a horizontal major axis. Okay, so that's our first one. This is one version of it. So the first thing we need to figure out is we need to figure out where the major axis is. Because what I'm saying is this one is kind of rotated 90 degrees. Well, now this becomes A, the up and down becomes A. This distance here becomes A. This distance left to right becomes B. B. Our focus is still C. But the way we write this equation is we are going to write this as still x minus h squared. We're still going to write it as y minus k squared. Still have the plus in there. But now what we're going to do is we're going to put the major axis under the y, because the major axis is like the y-axis. And this is also going to equal 1. And this is going to be our standard form of an ellipse with a vertical major axis. So the first order of business you have to figure out is, where's my major axis? And I'm going to show you how you figure out the major axis, where the bigger number is. We're going to be able to figure that out. So the way you are going to be presented this is there's a whole set of instructions here. And I'm going to go through these examples in class. I know it's a lot of words. It depends on where your major axis is, kind of the process we're going to follow. So what I am going to do here is I'm going to kind of walk you through kind of the logic of how we do these problems. I'm going to do an example, and I'm going to kind of show you the process we do. So what we have here is we have a standard form equation of an ellipse. It's going to tell me the vertices, it's going to tell me the foci. Well, what I want you to look at is I want you to look at what is constant there, what stays the same in all of the vertices and the foci. And if you look at that, what that is telling me is that x is constant. The x has a constant value. If the x has a constant value, if you remember, a line where the x is constant is vertical. What that tells me is that this guy is going to be a vertical ellipse because x is constant. That's a vertical line. We're going to have a vertical ellipse. So now what that means is since we're going to have a vertical ellipse, we're going to be putting the a squared goes under the y. The b squared goes under the x. So now the process in doing it is the first thing I want to do is I want to find the midpoint between the vertices. So what I'm doing is I'm trying to find the midpoint of -2, -8 and -2, 2. So the way I figure out that midpoint is, since the x's stay the same, what I want to do is I want to figure out what is the midpoint between -8 and 2. The way I do that, -8 plus 2 divide by 2, that gives me -3. So what that tells me is that the center of this ellipse, the midpoint between the vertices, is going to be, so again, I'm taking like this point here, and I know that the x's are always going to be stuck on that -2. The midpoint of the y split between the difference is -3. So what that tells me is, the color, that tells me that -2 is my h, and it tells me that -3 is my k. So now I've got my values of h and k. Now what I want to do is I want to figure out the length of the major axis. And the way I figure out the length of the major axis is this. The major axis is how far it is from the center to one of the vertices. So what I want to do is I want to figure out how far is it from -2, -3? How far is it to get to -2, 2? Because if I know how far it is from -3 to 2, that's going to be the length of my axis. So again, how far is it between that -3 and the 2, the number that's changing? Well, the way we can figure out how far that is we can do first minus last. So in this case, we're going to do first minus last. So we're going to do 2 minus -3. That's a keep, change. That tells me that the length of my major axis is 5. That tells me that my a is 5, which then means my a squared is 5 squared. My a squared is 25. So again, that's how we find our major axis. Now, to find our minor axis, it's a two-step process. To figure out your minor axis, we're going to use the other point we haven't used yet. We're going to look at the foci. We're going to look at the foci. And what happens is, again, the foci are going to be one of these points right here and here. So what we need to figure out is we need to figure out this distance between the center and the focus. The distance between the center and the focus, just so we know, I'll put it right here if we want to look at the distance between the center and the focus is referred to as the letter C. So what we want to do is we want to figure out letter C. Well, what we're trying to do again is we're trying to figure out what is the difference between -2, 1 to -2, -3. Because again, it's we're going from the center to the focus. So again, we're going to do the same process. What we're going to do is we can do this 1 minus -3, 1 minus -3, keep, change. That tells me 4. That tells me my C is going to be 4. That tells me my C squared is going to be 16. Now, there's only one formula you got to kind of keep track of on this. It's how you figure out your B squared. Your B squared is going to be equal to A squared minus C squared. And we just figured out that A squared is 25. C squared is 16. So that's going to tell me that my B squared is 9. So I have B squared equals 9. So technically b is going to equal 3. So now, lots of work to get to this point. I want to do x minus h squared, y minus k squared equals 1. And if you remember, we're going to put the a squared under the y. We're going to put the b squared under the x because we have a vertical ellipse. And now I'm just going to plug in numbers. So the way I'm going to plug in numbers is I'm just going to go right to my problem up top. -2 in for h. That's x plus 2 squared. B squared is 9 over 9 plus y minus k squared. K is -3, so this becomes y plus 3 squared over a squared, which is 25, equals 1. And that's my standard form of an ellipse. So it's a lot of addition, and some squaring. So what I'll do is I'll do another one just so we kind of have it. So again, if we look at this one, what stays constant here, if we notice, the x's change, the y's stay constant. And if you remember back to your Algebra 1 days, when you have a constant y, you have a horizontal y. So what that means is we have this as our ellipse. We have a horizontal ellipse. So that's going to tell me that the a squared is going to be under the x, and the b squared is going to be under the y. And I follow the same process. I want to find the midpoint of the two vertices of -3, 5 and 7, 5. Y can tell you right away that the y is going to stay the same as 5 because the distance, if you do 5 plus 5 is 10, divide by 2, you still get 5. What I'm going to do is -3 plus 7, divide by 2. -3 plus 7 gives me 4. 4 divided by 2 gives me 2. That tells me that the center of this is 2, 5. So my h is 2 and my k is 5. Now I'm going to do my major axis. My major axis is my distance from my center, 2, 5, to one of my vertices. And what I'm going to do is make my life easy. I'm going to pick the positive one. How far is it from 2, 5 to 7, 5? Again, this one here minus this one here. So you do 7 minus 2 equals 5. That tells me that my a is going to equal 5, which then tells me a squared is going to equal 25. For my minor axis, again, I want to figure out how far it is from the center, 2, 5, to one of the vertices. I'm going to go to the positive one because it makes my life easier. So how far is it from 2, 5 to 3, 5? That's going to tell me we're going to end up with 5 minus 2. So again, we're going to do that. 5 minus 2 is 3. That's going to tell me my c. So my c is 3, which tells me my c squared is 9. And using the formula, b squared equals a squared minus c squared. A squared is 25. C squared is 9. That tells me that b squared is 16. So I now know that b squared is 16, which then tells me b equals 4. And now to plug in the numbers, again, the way this works is x minus h squared, y minus k squared equals 1. I put the a squared under the x because it's horizontal. I put the b squared under the y because it's vertical. Now I plug in my numbers. This becomes x minus h, which is 2 squared, over a squared, which is 25, plus y minus k, which is 5 squared, over b squared, which is 16, equals 1. So that's how we do it when we're given those points. That's how we're doing when we're given those points. I'm going to pause this. I'm going to do a separate video that's going to kind of show you how you turn general form into standard form.